Okay, we're going to talk about the continuity of functions, okay? So most of our techniques that we're going to use in calculus from here on out require the function to be continuous, like a derivative or an integral, which you'll learn later. And a function is continuous if you can draw it in one motion without picking up a pencil. Okay, we typically look at the continuity at particular points of the function, which we will do below with this example, and determine where it's continuous and where it's discontinuous, okay? So f of x is discontinuous at, well, if you look at the graph from left to right, if you use your pencil and draw, you can see you'd have to pick it up at f of 1 to continue the line. Okay, so it's discontinuous at x equals 1. Okay, where else? Well, I'd keep going, and then right here, the function is actually up at 2. F of 2 is at 2, so that's where your function would go. Okay, so that means it's also discontinuous at x equals 2. Then if I keep doing my pencil, I can draw the rest of it, okay? So it's just discontinuous at 1 because we have a jump, and then at 2 because f of 2 is not where the graph is heading towards, okay? Then f of x is continuous at, well, if you think of the other points of the graph, at x equals 0, it's continuous. At 3, it's continuous, and at 4, it's continuous. 0, 3, 4. And then your graph stops, okay? At f of 4. All right, so in order for a function to be continuous at a certain point, it must fulfill all 3 of the following, okay? So f of c, the point where it's continuous, f of c, has to exist. So f of c exists, meaning it's defined there. It's not like a hole. It actually exists, okay? And not only does it exist, the limit as x approaches c also exists, okay? We were talking about that earlier. Does f of c equal the limit of x of c? We've kind of discussed that, okay? And so this means if there's a two-sided limit, that the left and right side limits are equal. Okay, which we should know that anyway. All right, and then, therefore, the limit as x approaches c should equal f of c. Okay, they should equal each other. If all of that is true, then you have continuity at that point, okay? So in other words, if the limit exists and the function is defined at the limit, then it is continuous. Okay, and obviously we need this if we don't have a visual graph already. If you have a graph, you can just look at it. Okay, so continuity at an endpoint. A function is continuous at its left endpoint, A, or its right endpoint, B, of its domain if the limit as x approaches A from the right of f of x equals f of A, okay? Or the limit as x approaches b from the left of f of x equals f of b. Okay, so you're looking at a left endpoint And if its limit to the right side of it is the same as f of a, as if you just plugged in a, then it's continuous. And if you're on a right endpoint, if you look at the limit from the left of f of x, and it equals the same thing as f of b, if you just plugged in b and they're the same, then they're continuous on their endpoints. Okay, or i.e. if the endpoint is closed, then it's obviously continuous. Okay, so using the definition of continuity, describe or determine if f of x is continuous at these 3 points. Okay, so, well, basically f of -3 needs to equal, or x of -3 needs to equal the f of -3, okay? So if we're looking at endpoints though, we've got to look at the sides. So if we look at -3, is your function continuous there? Well, if you look at the right, oh, this graph drops down and cut off. Okay, so let's draw this graph down and draw an open point, because that bottom half cut off. Okay, so continue this second part here, continue this down. Okay, so now let's look at f of -3. From the right side, the limit is down here. Let's say that's -2. Okay, and then f of -3 is actually at 2. All right, so the limit as x approaches -3 from the right, because it was a left endpoint, we got to look at the other side, does not equal f of -3. Okay, those are not the same, so no. And obviously you can look at the graph and tell, but why is it not the same? Because of this. Okay, x equals -1. Well, if you look at the left and the right side of this limit, it's obviously gonna approach 1, the same thing. And then f of -1 is 1, so it would be continuous there. Okay, well, let's say the limit as x approaches -1 of f of x equals f of -1. So yes. All right. Okay, and then the last one cut off here. Sorry about all this copy issues, all these copy issues, but x equals 0, let's look at that. So from the right side, or from the left side, if you look at that, it's approaching positive infinity. And from the right side, it's approaching negative infinity. Okay, so the limit as x approaches 0 negative does not equal limit as x approaches 0 positive. So this is no, not continuous there. Okay, that's it for the first page.